asymptotes and explain their significance. Okay, so we graphed this. So the options for e to any power is either increasing on all its domain or decreasing on all its domain. So this is never 0. So this function cannot have vertical asymptotes. I meant to say undefined, of course. So this piece will never be undefined. So that's why there are no vertical asymptotes. Okay? So all we can look at something like this is a horizontal asymptote. Again, how do we determine horizontal asymptotes? What do we need to do in order to, in case you forgot, what do we need to do in order to find horizontal asymptotes? For horizontal asymptote, we have to find what? Anyone?
The limit?
Yes. The limit as approaches negative infinity, and the limit as x approaches infinity. Awesome. 50 minus 15e to negative 0.354t, and 50 minus 15e to negative 0.354t. Yes, indeed. If you say this is too difficult to the concept, I will agree. If it's difficult for you to figure it out on your own by hand, that's okay. We can plug, if you think that that's easier, we can plug this function in the calculator and then plug in values of x bigger and bigger and bigger in the negative sense. The same thing here. Plug in numbers higher and higher and higher in the positive direction. If that's what you want to do, we'll do it. If you want me to explain step by step by hand, we'll do it by hand. Whatever works for you. You choose.
Can we do it in the calculator?
Fine. Perfect. So here it is. Go back, clear everything. Good. So we plug in 50 minus 15 e. The power is negative 0.354t and close. We go to make sure that I enter it correctly. Yes, it appears that I did. Second and table. And I'm going to go to negative 50 and then negative 100 and then negative 1,000 or 10,000. It's so small that the calculator cannot calculate it. So let's take a look at this. This is negative 7.3. E stands for 10 to power 8. So there are 8 zeros. So negative 0.00080 zeros and 73. Here, negative 4 times 10 to 16th power. So negative 0.15 zeros and then 4. So what does this mean? What is the answer here?
Is it negative infinity?
Yes. So a correction. Sorry about that. Thank you for saying the correct answer. So it's negative 7.3 times 10 to the 8th. So it's negative 7 followed by 3 and 7 more zeros. And then negative 4 followed by 16 zeros. Excellent. Perfect. Now the other direction. So I'm going to say 400. I'm going to say 1,000. I'm going to plug in 10,000 in the other direction. Where am I going? Not me, but the function, of course.
Positive infinity.
Careful. When we plugged in 400, we got 50. When we plugged in 1,000, we got 50. When we plug in 10,000, 50. Very good. Since this is a number, this is not a number. Since this is a number, what do we conclude? A number. The limit as x approaches infinity, I got a number. What do we conclude?
So horizontal asymptote.
Yes, indeed. This is the horizontal asymptote, not this one. So there is a horizontal asymptote, but only at infinity. Only, I swallow the L, only at infinity, not at negative infinity. So that answers the first, where is my button here? Okay, that answers the first part. Find any asymptotes and explain their significance, which means as time goes by, and of course, because we are talking about time, we really didn't have to go to negative infinity. There is no point. So the only thing I really needed was 0. Right? So 50 minus 15, which is 35. But so far, it's okay. Now, find any asymptotes, and we found only one. So what is the significance? As t increases without bound, v of t gets closer and closer to $50. That's all it means. As t increases without bound, the value of the stock, number of weeks, time passes by, number of weeks increases without bound. Well, of course, we're not talking about infinity, but you know that's how we say it. The value of the stock approaches $50. Okay, that's the significance of the horizontal asymptote. List any intervals where the graph of v is concave up or down. And then find the domain and range. After we graph it, we can look at the domains. So, how do I determine if it's concave up or concave down? From our concepts, what do we know for concave up and for concave downward?
Is it you have to find f double prime of x?
Yes, and study the sign in both cases. Good. So this is, we have to find, of course, v of t, sorry. But yes, the general v, the general f, which in this case, we are using v this time. So I don't want to confuse you, it's v. Good. So let's differentiate. I'm going to write the function here one more time, so I don't have to go back there. 50 minus 15 e to negative 0.354t. So we want v prime and then v double prime. The constant prime is 0, so I have to write negative 15. I have to multiply by this power, right? The number, negative 0.354 times e to negative 0.354t. Everyone understands what I just did, or is it not? Is it clear or not?
Could you repeat it one more time?
Yes. A v prime is 0. I'm sorry. 50 prime is 0. So I have to copy the negative 15. And when I differentiate this piece, e to u prime is e to u times the inner function prime. So e to a function prime is e to the function times the function prime. When I differentiate this, I only get this number. Is that okay?
Yes.
Perfect. So now I need to multiply these two. I don't want to change the screen. So 0.354. And I got 5.31. So 5.31 e to negative 0.354t. This is not what I'm looking for. This is what I'm looking for. So let's find the second derivative. In the same way, I have 5.31 times this number, 354, times e to negative 354t. And now I have to multiply these two. So I already have the 5.31 in, so times 0.354, and this is a negative number, negative 1.87974 e to negative 354t. Okay, so now we are asked, when is the function concave up and where is concave down? Well, this function is never 0. It will never be 0. This will never be 0, and this cannot be 0. Because remember the graph. It's either increasing on all its domain or decreasing. Never touches 0. Okay, so if that's not the case, then there is only one possibility. So always, I'm swallowing letters tonight. Always opening up or opening down, and we have to decide which one. We know that this is always a positive quantity, no matter what. Any e to any power is always positive. But there is a minus in front. So it's always opening upward or always opening downward. So this is a negative number. This is a negative number. And multiplied by a positive number always. So what will be the sign of the second derivative? So the second derivative will always be, or have what sign? Good.
Negative.
Excellent. So then which one is it? Does it hold water or it does not? Concave upward or downward?
Concave downward.
Exactly. Concave downward. When the second derivative is negative, the function must be concave downward. Awesome. Okay, find the domain and range. Let's go ahead and graph the function. The domain we know is 0 to infinity. Oh, I don't need to do that. I'm already sharing. So we have the function in the graphing calculator. And now careful, we know that the horizontal asymptote, you already told me, is 50. But now we have to adjust the viewing window because what I used before will not work here. So I know the function, because we are talking about time, cannot be, x cannot be less than 0. Maximum, I don't know. I'm going to put 30 weeks with a scale of 5. The value of the stock cannot be negative. So I'm going to put 0. The y maximum, it cannot be more than 50. That's the horizontal asymptote. And with a scale of 10. The function has to open downward at all times. It cannot change concavity. And we'll see what happens. What was v of 0? V of 0. Okay, hold on one second. So this is the function. V of 0, this is 1. So 50 minus 15. So when x is 0, when t is 0, this will be 35. Okay, and it goes eventually to 50, whereas second in the other page. So when t is 0, 50 minus 15, 35, and towards infinity will approach 50, always opening down. Okay, now we are ready to click on it. Ready? Oh, I didn't mean to do that. Why did I do that? I meant to change the viewing window so we can see that better. I want to go to 60 or maybe 70 to see those at the top better. Okay, so see, it's right here at 35. No, they're not overlapping. We know the calculator is lying to us. So this function goes closer, 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 closer to 50, but they do not overlap, and definitely not here. Okay, so this is the horizontal asymptote. At the starting point, when t is 0, the value is 35, and it continues to increase closer and closer, eventually, not here, right? Going to infinity. When t approaches infinity, the function values get closer and closer to 50 because that was, and it's always opening down, concave down. Okay. Any questions for me? So let's continue with section 3.4 finally. I know I talked too much. And we did talk about this. So here in 3.4, we're talking about absolute, max and min. And I just want to look at a few graphs before we analyze algebraically. So let me click on page 314. We discussed that. We're going to discuss it again right now. So we're given some graphs. We don't really need for the function. I just want to have a discussion, and then we'll choose a function in a minute. So